If nuclear reactors are so powerful, why haven't we ever seen one explode like an atomic bomb? Not in movies, not in history, not even in the worst nuclear accidents. This isn't luck, it's physics. Movies often portray nuclear power plants as ticking time bombs, one failure away from a nuclear blast. That image feels convincing, but it's completely wrong. In reality, a nuclear reactor exploding like a bomb is not just unlikely, it's physically impossible. Both atomic bombs and nuclear reactors rely on nuclear fission. That's where the confusion starts. But from that point on, everything about them is different. A bomb is engineered to release energy as fast as physics allows. A reactor is engineered to do the opposite, to slow the reaction down, control it, and extract energy gradually. Same fundamental physics. Opposite design goals. Let's start with fuel. An atomic bomb requires extremely high enrichment, typically more than 90% uranium-235 or carefully shaped plutonium-239. That level of enrichment allows a chain reaction that accelerates uncontrollably in microseconds. Commercial nuclear reactors don't use that fuel. They operate with low-enriched uranium, usually between 3 and 5% uranium-235. With fuel like that, a bomb-type explosion is simply impossible. The neutron population cannot grow fast enough, no matter what fails. Fuel alone still isn't enough to make a bomb. Nuclear weapons depend on extremely precise geometry, rapid, symmetrical assembly that traps neutrons and forces the reaction to run away. Reactors are designed to prevent exactly that. Fuel is spread out, neutrons are moderated. Control rods made of materials like boron absorb neutrons and can shut down the reaction in seconds or even automatically. And most importantly, reactors rely on negative feedback. As temperature rises, reactivity falls, hotter fuel fissions less, hotter coolant slows the reaction. The physics itself resists instability. At this point, you might think of Chernobyl or Fukushima. Even in those extreme scenarios, there was no nuclear explosion. Chernobyl involved a steam explosion followed by chemical reactions, not a bomb. At Fukushima, the reactors shut down as designed. The damage came later from loss of cooling, not from runaway fission. These accidents were serious, but they prove something important. Even under catastrophic conditions, reactors still cannot explode like nuclear weapons. The biggest difference is time. A nuclear weapon releases its energy in microseconds. That's what creates an explosion. A nuclear reactor releases energy over months and years. Even in a complete core meltdown, the energy release rate is thousands of times lower than that of a bomb. It's the difference between a lightning strike and a controlled fire inside a furnace. So why does this fear persist? Because explosions are dramatic. Fear spreads faster than physics. Real nuclear reactors are intentionally boring, heavily regulated, continuously monitored, and designed with multiple independent safety layers. They are not weapons. They are machines built to control one of nature's most powerful forces. So let's be precise. Nuclear reactors are not bombs. They cannot explode like bombs, and the laws of physics guarantee it. Understanding that difference is the first step towards separating real risk from imagined fear. In the next video, we'll explore the safest nuclear reactor designs ever built and how modern engineering pushed risk even further down. This is Reactor Atlas, and this is Nuclear Energy Explained.